Okay, this next lesson deals with inscribed angles. Okay, inscribed angles. Before we had central angles, which started in the center of the circle. Okay, here's our central angle. Now with inscribed angles uh, are on the outer end of the circle. Okay, so angle C here is an inscribed angle. Okay, and the thing you need to know about inscribed angles is that they are half the measure of the arc. So the measure of angle C is going to equal half the measure of arc AB. Okay, so if arc AB is, let's say, 100 degrees, from here to here, 100 degrees, then the measure of angle C is half of that. So the measure of angle C is 50 degrees. Okay, and that is just as review, the measure of this angle here would be 100 degrees. Okay, so inscribed angles are half the measure of the arc, the intercepted arc it forms. So this angle forms this arc, and it's half of that. So let's look at some examples that involved inscribed angles. Okay, the first one, we have the measure of angle the measure of angle B is 40 degrees, and we have to solve for x. Okay, so we know that in this problem here we have two segments, okay, in our circle, all right, that are congruent. So if x is the same here, then it's also the same over here. Okay, and the measure of angle B is 40, so AC, measure of AC, arc AC, is twice the measure of the angle. So that would be 80 degrees. Okay, so now we have three arcs. We have AB, we have BC, which is congruent to AB, and then we have AC. Alright, so x plus AC, which is 80, equals how many degrees? Well, we know a full circle is 360 degrees. So x plus 80 is 360. 2x plus 80 equals 360. Minus 80. Minus 80. 2x equals 280. Divide by 2, and we get x equals 140. So each one of these arcs is 140 degrees. Okay. Next one, let's solve for x and y here. Alright. Alright, we have a triangle that's inscribed inside of our circle. Okay, and this is the diameter here. Okay, we know that angle L is 60 degrees, so arc JK, which is the intercepted arc for angle L, okay, angle L makes this arc. Alright, so we know that JK is 120 degrees. Alright, we also have the diameter here. Okay, we know that the diameter is 180 degrees, therefore arc JL is 180, because this would be the central angle for this arc. Okay, but also we have angle K, which is our x value. Okay, angle K, alright, forms arc JL. So angle K is half JL. Alright, so x equals half JL. JL is 180 degrees. So half 180 is 90 degrees. Alright, so anytime we have a inscribed angle that goes to the diameter, all right, then it is a right angle. Okay, so if this is 90 degrees, this is 60 degrees, then y is 30 degrees. Okay, just following the 30, 60, 90 right triangle. Next problem, we have another triangle that's inscribed in our circle. Okay, and we know two angle measurements of the triangle. We need to find the measure of this arc right here. Okay, well, we know that this is 20 and this is 40. Okay, so we could use the triangle sum theorem, okay, and figure out what this is right here, because this plus 20 plus 40 will equal 180 degrees. Because the triangle, the sum of all the angles in a triangle is 180 degrees. So this, whatever that angle is, plus 60 equals 180. So that angle equals 120. Wasn't sure about that. So that's 120 degrees, okay, which means this arc that this angle goes to, all right, this inscribed angle goes to this intercepted arc, all right, this arc is double that angle measurement. So 2 times 120, and we get x equals 240. Okay, now we have just 10 here, and we have to find out x. What does x equal? Okay, let's try to figure out some of these things. You know, x is the intercepted arc for anything here? Not really, but we know that this right here is the inscribed angle for 180 because here's our diameter. So this angle right here is 90 degrees because it goes to the diameter. Alright? Just like on our previous problem. Alright, so if this is 10 here, and we know the whole angle is 90 degrees, then this right here is 80 degrees. This green section right here is just 80. That's 10. The whole thing is 90. Alright? That being said, we know that this, from here to here, goes with this arc right here. Alright? And if we're trying to find this arc, and we know that this is 80 degrees, well then x is twice 80 degrees, so x equals 160 degrees. Alright, last one. We have a quadrilateral inscribed in a circle. Alright, and we need to find the measure of this arc right here. Okay, so let's see. We know that a circle is 360 degrees. Okay, so we have 130 for this part. We have x for this part. And then we have this part right here, this part of the arc right here, or a circle right here. Okay, and we don't know it. We could find that out, and they all equal 360. Well, we know this angle's 80, so from here to here is twice 80, which is 160 degrees. So 130 plus x plus 160 equals 360. Combine like terms. And solve for x. And we get x equals 70 degrees. Okay, so the measure of this arc right here is 70 degrees. Okay, please feel free to ask me any questions. And when you're practicing this, you should be getting similar problems. So just try to tie in what we've done here into your practice problems.